All right. So, section 6. Here's the basic premise that we have. I need you to imagine the room. I need you to imagine the floor as one plane, 3 dimensions. Where does the floor intersect with the front of the whiteboard? Down there at the brown baseboard. If you had to classify where a plane intersects with another plane, what would you call that? A line. Okay, so 2 planes intersect in a line. Now, third plane. I want you to think of the wall over there, not where the divot is, but kind of the wall where the clock is. That's a third plane. Now imagine that plane by the clock and the front wall. Where does that intersect? Another line. Okay, so I'm going to call this line down here at the baseboard line A. I'm going to call that up there line B. You see the 2 lines. Where does line A intersect line B? At what point? Point at it. Right down there. Okay? So this is what we're going to do. What we're looking at in section 6 is the equations of 3 planes in 3 dimensions. Effectively, in our initial problem, we had plane A, B, C, D, plane D, C, F, E, and plane C, B, G, F, and they all intersect at point C. Okay? So we're trying to find the intersection of 3 planes. Step 1 will be to find the lines. Once we have the lines, then we find the point. The only thing that's new today is taking a plane and finding the line. Everything else is review. Okay? So we need some color. So let's label equation 1, that first one up there, with blue. So put a blue dot next to it. We're going to have equation 2 be red and equation 3 be green. As you look at these 3 equations, which variable, using the elimination or addition method, whatever you want to call it, is easy to drop out from a vertical standpoint? Y. The y one? All right. So how would you go about dropping out y? Aaron, what would you do? What would you combine?
What do you mean?
Well, if you combined like the blue equation with the red equation, would that work?
The red and green.
The red and the green?
Yeah.
Okay, now how are you going to...
No, it's the blue and the green.
Okay, so let's do this. Copy down the blue equation again, down in the space down here. 2x plus y minus z equals 5. Please cross your z's. Then switch colors to green. X minus y minus z equals 0. So we're going to combine these 2 equations, and the purpose of those, once again, was to drop out the y's. So we have 3x minus 2z equals 5. I'm going to put a box around that, and I'm going to call that equation A. That is our first equation of a line. So I have one line. What do I need to now find? The other line. Okay, remember our 3 walls? The front wall, the floor, and the side wall. What walls have I used first to find the baseboard? The floor and the front wall. What walls do I need to use now? The side wall and something. So which equation have I not used? Red. Okay, so switch to red, come down here to the bottom, and copy down the red equation. 3x minus y plus 2z minus 1. All right, what equation can you combine red with to drop out the y variable?
2x plus y.
Blue or green? Okay, blue. So let's copy down blue again. 2x plus y minus z equals 5. let's add those up. Do the y's drop out? Leaving me with 5x plus 1z equals 6.
No. Equals 4. It's a negative.
Oh, is that a negative 1? Sure enough, thank you. Nice catch, Julia. That would have come back to haunt us. Okay, let's call that equation B. Now, let's just talk about what we've done so far. We combined blue and green to get one line. We combined red and blue to get another line. Now we're going to combine these two lines and get what?
Point.
A point. What I've just done is everything that is new. Is that pretty straightforward? Okay, let's transfer these two equations, A and B, over to the top of the next column. 3x minus 2z equals 5. Equation B, 5x plus 1z equals 4. Now with your elimination skills, how can you eliminate either x or z? Talk to me here. Which one lends itself to eliminating easier? Lane?
Multiply equation B by 2.
Okay, so everybody, let's put a little red 2 out to the side. And we're going to multiply it. That gives me 10x, 2z, and 8. What I made a mistake last night, Lane, as I was doing our notes ahead of time, I forgot to multiply the 4 by 2, and the rest of the problem just fell apart. So be careful you distribute, Jessica, kind of to all the different parts of your equation. All right, let's add them up. Realizing, guys, we're adding equation A and the red equation. 13x equals 13. How convenient. What does x equal? 1. I now have x equals 1. I'd like to get the value of z. Which equation would you like to use to get z? One of the original 3, or A or B? Which is the easiest? Which just has a z all by itself? Equation B, right? So let's go to B. We have 5x plus z equals 4. 5 times 1 plus z equals 4. What's the value of z?
Oh, no, 9.
Third time's the charm.
Negative 1.
-1. Thank you, Julio. That way, forevermore, no one will know who Julio is. All right. So now I have the value of x, and I have the value of z. What value do I need? I need the value of y. So I'm going to go up, and I'm going to use one of the original equations, either red, blue, or green, to find my value. Which equation up there, red, blue, or green, looks the easiest to use?
Bottom one.
The bottom one. Okay, I would agree. X minus y minus z. X minus y minus z equals 0. Let's put our values in. 1 minus y plus 1 equals 0. That's 2 minus y equals 0. Do we agree that y equals 2?
Yeah.
Okay. So I have my 3 values. Now I need to check. Here's the key. Which equation did I use at the very, very last step? Which color?
Green.
Green, right? And this is why I'm trying to change colors to keep things straight in our minds. If I'm going to check here, Rebecca, I've got to use either blue or red. It doesn't matter which one you use. So we're going to give you a choice. Which one do you want to use, Rebecca? Okay, so this side, you guys are going to check with the blue equation. Over here, you guys are going to check with the red equation. It should work. So you guys plug into the blue equation, we'll plug into the red equation. Don't plug into the green equation because we know that one's going to work. (3x minus y plus 2z equals -1). 3 times 1 minus 2 plus -2 equals -1. 3 minus 2 equals -1. Check. Okay, the red one worked. Did the blue one work?
Yes.
Okay, so that's a good indication that obviously we have the correct point of our 3. So let's write our ordered pair. And ordered pairs are written x comma y comma z. So 1 comma 2 comma -1. Now, let's kind of review what we did. We started with 2 planes and intersected them to get a line, equation A. 2 different planes, intersected them to get a different line, we call that B. Then in the second column, we just combined A and B to get the values. Very, very straightforward. Let's move on. Let's do some analyzing here. Top one, we're going to make blue. Middle one, we're going to make red. Bottom one, we're going to make green. Analyzing. Which variable do you feel is the easiest to dump? And you're going to have to give me a reason why. So
Y.
The variable y?
For the first 2.
So you feel like you could...
Well, no, I think Z might be easier.
Z might be easier?
Yeah, because you just want to do.
Because you could use the red equation for both. You can combine red with blue to drop out Z. And you combine red with green to drop out Z. Are we going to need some scalars here?
Yeah.
Right, that's okay. We can do scalars. What's your scalar on blue? 2. So I'm going to put a little 2 outside there. I'm going to draw a line down here. And we're going to multiply by 2. Max, can you do it for me?
Yes, so it would be 2x plus 6y minus 2z
Don't forget to cross your Z.
equals -8.
Good. Do I need a scalar on red?
No.
Okay, so that stays the same. 2x minus y plus 2z equals 13. Who can add them up? Come on.
Oh.
Go.
4x. No, plus 5y equals 5.
Okay, what are we going to call this? Equation A. What formula must you use in the next step?
Green.
Have to use green, right? How are we going to manipulate green?
Same way.
Multiply by 2 again?
No.
Okay, so I'm going to put a little 2 here and draw a line through it and come all the way down. All right, so 6x negative 4y negative 2z equals negative 18. Do you agree?
Yes.
And we're combining that with an unchanged red, true?
Yes.
So the red's going to come down as well. So 2x minus y plus 2z equals 13. And there I see the positive 2z and the negative 2z, which was our whole purpose, Allison. So we combine these together. I get 8x. I get negative 5y. Do we agree? Is negative 5? Okay, and we call this equation B. All right, before we jump on, summary. We took a plane and a plane, intersected, we get a line A. Another plane, intersect, then we get the line B. We now have 2 lines. What do we do with the 2 lines? Find where they intersect to make a point. All right, Owen, Amy, and Jessica. I'm going to have you take the next step. So we've got 4x, 5y, and 5. That's equation A. We've got 8x minus 5y equals negative 5. That's equation B. All right, the three of you, take it from here. Go.
We have to combine them, so it's 12x and 5y.
The 5y, that's convenient. No scale. No, might we need a scalar here? You could, maybe, but we didn't here. So, and that equals what? 0. So what's x equal? 0. That was simple. Okay? Keep going. Loredana, Michaela, Julia, and Annalise. We have x. We can now find...
So the blue equation. So you do x.
Well, here's my thing. If you put this into the blue equation, you're going to be introducing y or z back into the problem. Look up here at A and B. Okay, go ahead.
So use A.
Okay, so that's 4x plus 5y equals 5. So that's equation A. What do you want me to do with it? Plug in 0. So tell me, what does y equal? 1. All right, we're 3/4 of the way there. Aaron, Simon, Peter, and Rebecca. I need to find the value of z. Give me your thoughts. How do I find z? I have x, I have y. Where is there an equation with z? Aaron, take it away.
You go back to the first set of the blue, red, and green.
Okay, which one do you want to use?
I chose blue.
Okay, pretty simple. So let me recopy blue. X, whoops, I might as well do blue if I'm going to do blue. X plus 3y minus z equals negative 4. And so what do you want to do with my numbers now? Plug them in?
Yeah, you plug all the x's and y's in.
0, 3, z, negative 4. The z goes over and becomes positive. The negative 4 comes over 7.
Yeah, I guess so.
Do you guys agree with 7? What equation did he use to solve that with? What color? Blue. So what color must I use to check it with? Not blue. Yeah, I think that's the best answer. Not blue. Anything but blue. All right, so let's check it. Green or red, your pick. Green, okay. 3x minus 2y minus z equals negative 9. Let's plug it in. X equals 0, y equals 1, z equals 7. Is negative 2 minus 7 negative 9? Yes. Could you have checked it with the red equation? Yeah. All right, how do I write my answer? What's x? What's y? And z? 7. Questions? We're not quite done, but questions at this point. Are the steps pretty straightforward? You kind of have part 1, where you get the 2 lines, and part 2, where you get the point. The only important thing, Lordon, is you got to make sure you use all 3 equations in the first scenario. 2 in the first one, 2 in the second one. I don't care which one you match up with. And go from there. All right, I made a little bit of a typo. I apologize here. Take out your white marker and erase 11. I love that new white marker that I have. Was that thanks to you, Julia? Well done. Julia Netzley, technician extraordinaire, ladies and gentlemen, for years to come. All right.
But is it as useful as flattening lines?
More useful than flattening lines. Whatever flattening lines got us, nothing but grief.
Take out what?
Take out the 11 and replace it with a 10. Wait a minute. Yes, the assignment just got longer. But wait, there's more.
Oh.
Yeah, there's one more problem now.
More problems.
No, look what I did for you.
Yeah, so when we turn it around, we'll do just.
Yeah,
So you can clip off of here. I thought that would be nice.
Yes, thank you.
All right, now what I want to do is we've got about 10 minutes, and I want to do at least one of these problems with you. And your choices are either 10, 11, or 12. And I want to talk through one, and I want to do a different one. So which one do you want to start by doing in terms of practice? 10? Okay. So what's nice about 10?
Actually, no, let's do 13.
You want to do 13? 13 was not one of your choices.
11.
12. All right, we're going to vote here. Who wants to do 10?
That's easy.
3 votes for 10.
I
11.
just take my
No.
2 votes for 11. 12. 2 votes, 3 votes. 4 votes for 12. 12 wins. And then the rest of you are like the general population who didn't vote. All right, so we're going to do number 12 together. All right. So there we go. We have a large space. Number 12. We have my blue equation, my red equation, my green equation. I need to create 2 new equations, and each of my new equations may only have how many variables? 2. Now, what's beautiful about what we've given ourselves right now? Do you see equation 3? What's nice about equation 3?
It's a little bit resentful.
It already only has 2 variables. So we already, guys, have equation A, which we can put in purple. R equals 3s plus 1. Make sure when you're doing your s's, you do little curls at the end so it's very clear they're not 5s. Now, how do I get rid of the t in either the first equation or the second equation? We're not using elimination this time. We're going to use what? Substitution. So I'm going to highlight in t here. We take that t and replace it with that t. See that? So here we go. Come up here. 5r, I'm in blue now, minus 4s minus 3 parentheses equals 3. And what goes in that parentheses?
S plus R.
S plus r in red, because we're pulling from the red equation. So now let's just combine our like terms. 5r minus 4s minus 3s minus 3r equals, what's that number? 3. 5r minus 3r is 2r. 4s negative minus another 3s negative is negative 7s equals 3. Do I now have an equation with 2 variables that are r and s? That's equation what? B. Is this one falling into place nicely? What method do you want to use to go further? Elimination or substitution? Substitution. Because what do we know about r? What does r equal? Yeah, 3s plus 1. So here we go. Substitute into the B equation. 2 parentheses minus 7s equals 3. What goes in the parentheses?
6s plus 2.
You're ahead of me, but yeah, I'm with you. I'm with you. 6s plus 2 minus 7s equals 3. Negative 1s plus 2 equals 3. Negative 1s equals 1. Yeah? So s equals negative 1?
Yep.
Do you see the green equation? What does the green equation use in it? S. And if we plug in the s, what should we get? R. So r equals negative 3 plus 1. What does r equal? negative 2. We now have S and we have R. What can we find? T, using the red equation. T equals S plus R. T equals negative 3. What equation did we use to solve for T? Red. What equation should we probably check in?
Green.
Well, we kind of just used green, didn't we?
So blue.
Probably we should check with blue. So let's go back to blue. 5, negative 2, minus 4, negative 1, minus 3, negative 3, equals 3. Did I get those right? Negative 10 plus 4 plus 9 equals 3. Negative 10 plus 13 equals 3. We got it. How do I write my letters? Alphabetical. So we write them as negative 2, comma, R, S, T. Now, let's take a look here. Did we, ooh, there's that flatten thing. I'm going to flatten this. Are you sure you want to flatten? Oh, yes, because I just love flattening. It just makes me feel good. Did we still need to get an A and a B? Yeah. And then we use those. Now, how is this one different than the other one? Here we use substitution. On problems 1 and 2, we use what? Elimination. Does it really matter? No. Questions? Any questions? All right. So, the rest that we're going to have to do, all you have to do on that number 12 is just do a nice big snip and drop it into OneNote. Hopefully that'll be easy.